Okay. Hello, good morning everyone. Welcome to today's class. We have seen synchronous counter. Okay, so it was a 4-bit counter, and we have seen how this is operating. And you can, I've told in the previous class as well that if you want to increase the number of count or the flip flop or the state, what we can do, we can add one flip flop here, and we have to add we have to add one more AND gate like this. This is JK sorted. Then we need to have one AND gate, this input, and we have to give the second input as this one. So this will increase the count. Okay. So like that. Okay. So this 4 by 4 flip flop we can count up to 16, and if we add the next flip flop we can count up to 32. Okay. And similarly we continue to add the flip flop and the AND gate. So what we will have, the count will increase. Okay. So this we have seen in the previous class. Okay. So you can see that next flip flop inputs are the previous flip flop inputs with the AND gate. Okay. So this process is continued. Okay. After second flip flop you can see in the first flip flop the inputs are 1 1. In the second flip flop the inputs in the previous output is the input, and in the third flip flop the output is not directly input to the third flip flop is not directly given, but it is the AND operation of the previous two outputs. Then for the fourth flip flop the output is the AND operation of previous three flip flop outputs. Similarly, if the fifth flip flop was there, the input for the fifth flip flop will be output of previous fourth flip flop with the AND operation. So this is how we can continue to increase. Okay. I hope you understand this. So now we move ahead to see the next part. Okay. So this is what I was saying. Each flip flop should have its J and K inputs connected such that they are high only when the outputs of all lower orders flip flops are in the high state. Okay. So if you understand and remember this statement, so this gives us the idea why we need to connect the AND gates. Okay. And also you remember that if you want to change the fourth bit, okay. So when this fourth bit MSB will change when the previous three are high and the clock appears, so this will become high and all will go in the lowest state. So this is a normal count, you know it better. Okay. So this statement is the same what I've told you. You know, if we talk about the advantages of synchronous counters over the asynchronous counters, so one of the clear advantage is the delay. Okay, because in this case, delays are not added. Okay, because output of each flip flop comes at the clock only. Okay, so whenever the clock comes, the output of each flip flop may or may not change. Okay, so it depends on the clock, not on the previous flip flop. Okay, as it was the case in the synchronous counters. In the synchronous counters, the output of the previous flip flop goes to the clock of the next flip flop. Okay, and this continues, so that gives a ripple effect, and the delays are added. If we are having the n flip flops in the synchronous counter, we have n flip flops, So the delay and the delay for each flip flop is t. Okay, so the delay for this will be n t naught. Okay, so this will be the this much will be the delay. So if we increase the counters, the delay will continue to increase. Okay, if the delays are increasing, so you can see that this was the condition on the time period of the clock. So if the delays are increasing, we have to increase the time period of the clock, because for the normal operation of the flip flop, the time period of clock must be greater than the all the delays. Okay, so when we use high value of t, in that case the frequency of the clock reduces. This we have discussed already. Okay, what happened in the synchronous counters? The greatest advantage is the delay. Okay, you can see that for each output, I'm showing you the diagram. Yeah, for each output you can see the output of b comes depending on the clock. Okay, because once a is high, okay, so now it waits for the clock only. Okay, so it will change only at the clock. Again, the output of c changes. Okay, and what is the delay? Can be maximum delay. Okay, so the output of c changes, the its processing of this flip flop and the processing of this AND gate. Okay, similarly for the D, the processing of this AND gate and the processing of this clock. Sorry, this flip flop. So the out maximum delay is caused by, so the maximum delay is caused by this flip flop and delay of AND gate. So this is the maximum delay that we will have in the synchronous counters. So delay of one flip flop and delay of AND gate. Let's say this is T1. Okay, so this is the only delay. So the total delay that we will face in this is T naught plus T1. Here the delay and this delay remains same. Whatever the size of this counter, that this delay will remain the same. But here you can, in the asynchronous, the delay increases with the number of count and the number of flip flops. And this delay T naught plus T1 is always constant. What is T naught? T naught is the delay of the flip flop and T1 is the delay of AND gate. So this continues, and this is one of the advantage of using the synchronous counter. Okay. What can be the drawback of the synchronous counter? Why we should not use synchronous counter? What are the negatives of the synchronous counter? So obviously you can remember. Oh, okay. Obviously you can see the difference that the synchronous counter requires more circuitry. A synchronous counter there were no AND gates, but in the synchronous counter we do require AND gates. Okay, so as we increases the count or the number of bits, okay, so what happens? We need to increase one flip flop with one AND gate. Okay, so always it increases the flip flop and the AND gate. Two things add together. And in the previous case, the ripple counter only the flip flop was required. I hope you understand this. So the advantage, you understand what is the advantage of this synchronous flip flop, and the disadvantage also you understand. These are two ICs, some of the ICs which are famous for the counters. Okay, so the 74ALS 160 74HC 160 synchronous. These are for the synchronous decade counter, and this 74ALS 161 163, and this is the mod 16 counter. Okay, so these are the some of the example of the counters. Okay, ICs that are directly available. If we want to use it as in the uh, for our practical purpose or any operation, so these are the ICs that we can directly use as a counter. Okay. Next, there is a question. I will ask you to first. I'll give you 2-3 minutes for solving this question. So you have to find the answer by yourself. So the question A part says that determine F max for the counter of फिगर 7.17 जो हमने ऊपर फिगर देखा काउंटर देखा है उसके लिए हमें एफ मैक्स निकालना है if TPD means the delay of each flip flop is 50 nanosecond and delay for each AND gate is 20 nanosecond. Okay, and compare this value with F max for a mod 16 ripple counter. Okay, so first part is you have to calculate the F max for this synchronous counter, and in this also after calculating this you have to compare this F max with the mod 16 ripple counter. ठीक है, so आप रिपल काउंटर में फ्लिप फ्लॉप जो हमारे 50 नैनो सेकेंड उसका डिले है. Okay, so you can calculate the total delay of a 4-bit ripple counter using this each flip flop delay and then compare this with the synchronous counter. Okay, what must be done to convert this counter to mod 32? Okay, so mod 32 करने के लिए हमें क्या changes करने होंगे? You have to see this. Determine F max for the mod 32 parallel counter and then do this operation. Okay, so I'm giving you 2-3 minutes. Try calculating quickly and give the answers in the chat. If you have finished any of the answer, you can write in the chat. Okay. So if you finish the first answer, what is the F max value? You can write in the answer. Then you can compare what is the F max for mod 16. Okay. So you can compare mod 16 ripple counter. Then that is the comparison. Then you can see for the second part. Okay. So I have explained all of the second part to you, but here you have to answer how much you have answered. So I'm waiting for your answers. Till now, no answers. Uh, is that difficult? No, you haven't submitted any answer till now. Okay, let me solve it for you. So first of all, what we have been asked is the F max. So you know that the time period of the clock should be greater than or equal to the total delay. What is the delay in this synchronous counter T0 plus T1? Okay. So what T naught is the delay of the flip flop, and T1 is the delay of the AND gate. So what should be the maximum value? The time period should be greater than 20 plus 50 plus 20. This gives us the 17 nanosecond. Okay. So minimum time period that we can select for the clock is T min. The clock is 17 nanosecond. Okay. So we can select the minimum time period of. If we select smaller than this time period, then the circuit will not function properly. So this is the minimum. Okay, we cannot take smaller than this. So at least the minimum time period possible for the clock is 17 nanosecond. Okay, so if the time period is minimum, and you know that the frequency and time period, what is the relation between the frequency and time period? It is this. Okay, so if T is minimum and its inverse will be maximum. So this will be F max. Okay. So what is T is 1 over 70 nanosecond. And when you will calculate this, I know from the answers this would give us 14.3 megahertz. Okay, so this is the कितना आ रहा है यहाँ नीचे आंसर्स में ये दिया हुआ है तो मैंने ये लिख दिया अगर आपको थोड़ा बहुत कुछ वेरिएशन आ रहा हो so you can keep it like that ठीक है कैलकुलेशन में थोड़ा बहुत वेरिएशन हो सकता है ठीक है राउंड ऑफ करने में या हाँ सिंक्रोनस के लिए ओके यस एक आंसर आ गया अच्छा ठीक है तो सिंक्रोनस के लिए सही आंसर आया है ठीक है सो 14.3 मेगाहर्ट्ज जो है वो सिंक्रोनस की फ्रीक्वेंसी होगी और रिपेल की फ्रीक्वेंसी क्या होगी तो रिपेल अगर हम 4 बिट यूज कर रहे हैं 4 बिट रिपेल काउंटर में कितने फ्लिप फ्लॉप होंगे 4 तो उनका डिले कितना हो जाएगा 4 इंटू टी नॉट ठीक है सो टी नॉट की वैल्यू मैं डायरेक्टली यहाँ पे लिख देता हूँ सो टी नॉट इज 50 so this will be 200 okay so this will be the total delay okay so this will be the total delay 200 so what will be the frequency for the ripple counter this will be f max for ripple this will be 1 over 200 and this gives us 5 megahertz okay so, and you can see that the frequency of the synchronous is more than double okay almost 3 times of the frequency of the ripple counter okay so you can see that this is one of the advantage that we enjoy with the synchronous counter okay so frequency is almost 3 times of that of the ripple counter for the okay so I think this calculation is clear to everyone and I have got the second answer also one of the friend has got the second answer so say what the second answer says is that so yeah that answer is also correct I think so what was the second question let me go to the question what must be done to convert this counter to mod 32 yeah so answer is to get 5 is 5 n equals to 5 means we need to have 5 flip flop okay so 5 we have to add 4 flip flops are already there so we have to add one flip flop with a AND gate okay so that answer is also correct flip flop is needed with a AND gate. As I told you that without AND gate it will not work. So we need a flip flop with AND gate, and the AND operation will be among the all the previous inputs. Okay. Determine F max for mod 32 parallel counter. So what will be the F max for mod 32 parallel counter? C part. What will be the F max for mod 32 parallel counter? This is the easiest question. Yeah, correct answer again. So the answer for the F max for the mod 32 is again 14.3 megahertz, because the frequency of the synchronous counter does not depend on the number of states. Okay, it depends the delays. It depends on the delay of each flip flop and the delay of a AND gate, and this gives us the frequency. So even if we use the 10 flip flops or 20 flip flops, the answer of this will remain the same. Okay. So if we want to increase this frequency, what we have to do? We have to reduce the delays of the flip flop and the delay of the AND gate. Okay. So that is it about this question. So these are the calculation, and you will be having the answers as well with you. Okay, so there are some questions for you. You can, if these are review questions. Now by this time you should know all these three. What is the advantage of a synchronous counter over an asynchronous counter? What is the disadvantage? I think you know both of these. How many logic devices are required for mod 16 mod 64 parallel counter? Okay, logic devices mean how many AND gates are required for mod 64 parallel counter. हमें flip flop नहीं count करना है आप, ठीक है, सिर्फ लॉजिक डिवाइसेज हमें AND गेट काउंट करना है. So mod 64 parallel counter के लिए कितने AND gates की जरूरत होगी? So I think you can calculate it. Then we have what logic signal drives JK inputs of the MSB for the counter of question 2. Okay, so अगर हम mod 64 बना रहे हैं, we are making a mod 64 counter, parallel counter. So how many? So what will be the logic of the final flip flop? Okay. So what should be the input here? What should be the input here? Okay. What should be the input here? So this is the which flip flop is this? This is 5. Yeah. One answer I think. Yeah. Yeah. Gate 5 is required. So what will be this logic? All the previous inputs should be here. So this will be the sixth flip flop. This will be the sixth flip flop. So the previous 5 inputs should be there as a AND gate. AND gate input A, C, D, E. Okay, so all the inputs should be here as a all the previous output should be here as a the AND gate. Okay. किसी ने अपना माइक्रोफोन ऑन कर लिया है, प्लीज अपना माइक्रोफोन बंद कर ले. Unnecessary noise is coming here. Okay. So these are the answers of all these flip flop. All these, sorry, all these review questions. Next we move ahead. We talk about the synchronous down and the up counters or up down counters. Okay. Please turn off your audio, microphone. Please use the microphone is on. महवेश, अपना माइक्रोफोन आपने क्यों ऑन किया? Okay. Okay, so now we talk about the synchronous down and up down counters. Okay, so हमने asynchronous down counter देखे थे. So ये वैसे वहीं से ड्राइव होता है. और what was the there in the previous state output? Okay, in the asynchronous counters, if you are using the up counters, so the output of this flip flop was going into the next flip flop as a clock. Okay, but and when we are using the down counters, the complement of the output was going as the clock for the next step. Okay, so these were the two cases. When we are using the down counters, the output of the complement was going as a clock. When we are using it as the up counter, the output of the first flip flop is going as the clock to the next flip flop. Okay, so same thing holds here. Okay, when we want to use down counters in the synchronous mode, so what we have to do, the complement outputs. So here we get the a, here we get the a complement. The complement output should derive the next state. Okay, so this is important thing. The next complement output should drive the next state, and also the logic, whatever the logic is constituted, means going into the AND gate, that is also done by the complements of the previous two states. Okay, so this is done like this if you want to make the down counter. Okay, okay. So this is how the down counter is constructed. Okay, so we will see a general circuit where which we can use as both down counter and the up down counter. So we can make a circuit which can be used as a down up down counter, which can for some count it can count up, and then after some that count it will count as the down counter. Okay, okay. So without you can make this part. Okay. This part is up to you. Okay, so you can make it a parallel down counter can be constructed in similar manner, that is by using the inverted flip-flop outputs to drive the following JK inputs. Okay, so I have told you, and you can do this by yourself. In the next part, what we are going to do is we are going to make a up and down counter. Okay, so there we have to give a control input, and this control input is this up down up slash down bar counter. Okay, so when this control input is 1 means up. So the name of the control input is given as up slash, okay, let me write it by this, up slash down and down bar. Okay, down bar we are using means the complement. Okay, when this is 1 it means up is enabled, and down bar is high, it means down is low. Okay, so what is the meaning of this line? Up, so this is the single input. Okay, there is no two input. The name of the input is, this is the control input, and the name of this is control input. Okay, this controls our circuit. Okay, whether we want to count up or we want to count down depends on this value. Okay. So what this input means, the input name is up slash down bar counter. So up slash down bar counter is 1. Okay. So what it means? Up is high. Okay. So it means this will count as up counter. Okay. So down bar is low. Down bar, you can see that I'm telling you separately. So down bar is 1. It means down is how much? It means down is equal to 0. Okay. So down is 0. Okay. So this is the control input. So if you want to make this counter count down, so what we have to do? We have to make this, sorry, input like this, up slash down equals to 0. Okay, when this is 0, up equals to 0, down bar equals to 1. Down bar equals to 0, and this gives us down equals to comes out to be 1, because down bar is 0, so down comes out to be 1. So this is the control input that we will be using. Okay. So instead of wasting time here reading this whole theory, we can go to the circuit directly. Let me remove these drawings, all the drawings. Yeah. Okay. So let's see in the circuit. So this is the circuit. Okay. So it may be looking a bit complex, but this is a circuit of up-down counter. Okay. So here more logic circuitry is there. Two AND gates, one OR gate, two AND gate, and OR gate. Okay. So these AND gates and OR gates. Okay. If we remove this OR gate, if we remove this AND gate containing this B inputs, okay, this would become the down counter. Okay. If I remove this part, okay, and connect this directly here, this will become the down counter. I remove this and connect this directly here, this would become the down. Okay, you can understand this. Is there any question in the chat? अच्छा, क्वेश्चन 3 किसी ने पूछा था. क्वेश्चन 3 ऊपर जो बात निकल गई. I'll upload the video, you can check it again. Okay. Okay, so this is the case. So I told you, if we want to make the down counter directly, how we can use it. Okay, how we can use it to make it the down counter. Okay, so we remove this circuitry and this two, this AND gate and the 1 and 2 AND gate we remove, and this OR gate, and directly connect this 3 and 4 to the next system. Okay. And in the first case, we also need, because we are using this control input here, you can see this is our control input. We are also using this control input here. So so this is input is here, and this is when this is high. Okay, suppose when this is high, it should count up. Okay, so when this is high, this NOT gate will be, output will be 0. Okay, and this output will always be 0. Okay, because one of the input is 0. Okay, but our अभी हम इसको क्या कर रहे हैं, अभी हम इसको सिर्फ और सिर्फ इससे हम क्या बनाना चाह रहे हैं, अभी मैं आपको सिर्फ और सिर्फ डाउन काउंटर बताना चाह रहा हूँ. तो कैसे होता है हमारा, कि पहले वाले में कोई NAND गेट नहीं होता है, पहले वाले में कोई AND गेट नहीं होता है. ठीक है, तो इस AND गेट को भी रिमूव कर दीजिए. ठीक है, तो मैं आपको अभी सिर्फ इससे सिर्फ और सिर्फ डाउन काउंटर बता रहा हूँ. तो हमें ये भी हटाना है, ये भी हटाना है, ये भी हटाना है, ये भी हटाना है. ठीक है, और हमें क्या करना है, इसको भी हटा देना है, इसको भी हटा देना है. ठीक है, इस इनपुट को डायरेक्टली हमें कहाँ दे देना है, यहाँ पर कनेक्ट कर देना है ना. मैं इसको थोड़ा चेंज कर देता हूँ, कलर बदल देता हूँ. ठीक है, तो हमें इस इनपुट को डायरेक्टली यहाँ से निकाल करके और इसमें कनेक्ट कर देना है. ठीक है, तो ये हमारी पहली स्टेज में ऐसे ही होता है। ठीक है, पहले स्टेज में डायरेक्टली कनेक्टेड होता है। सेकंड स्टेज में क्या होता है, दोनों की इनपुट जो है उनका एंड ऑपरेशन जाएगा कहाँ पर, नेक्स्ट स्टेट में। तो सेकंड स्टेज ही है। ठीक है, ये वाला लाइन तो मैं हटा दिया क्योंकि हम यहाँ पर अप डाउन काउंटर नहीं, सिर्फ और सिर्फ डाउन काउंटर की बात कर रहे हैं। तो मैं आपको बता रहा हूँ कि हम कैसे इसको एक्सप्लेन कर सकते हैं। ठीक है, अब हम यहाँ पर, तो हमें ये वाला इनपुट तो नहीं होगा क्योंकि अभी हम इसकी बात ही नहीं कर रहे हैं, कंट्रोल इनपुट की बात ही नहीं कर रहे हैं। अभी हम सिर्फ और सिर्फ डाउन, इसमें से ही डाउन काउंटर के सर्किट निकाल के मैं आपको बता रहा हूँ कि कैसे डाउन काउंटर बना सकते हैं हम। ठीक है, तो ये दोनों का है, ये सर्किट अप और डाउन दोनों काउंटर का है। ठीक है, इसमें से सिर्फ मैं आपको डाउन काउंटर सर्किट दिखा रहा हूँ। ठीक है, तो ये रिमूव कर देना है, इसको भी रिमूव कर देना है, इसको भी रिमूव कर देना है। तो डाउन काउंटर में क्या होगा, नेक्स्ट इनपुट जो है यानी कि थर्ड थर्ड बिट का इनपुट जो है वो क्या होगा, प्रीवियस टू इनपुट्स का एंड ऑपरेशन होगा। लेकिन हम डाउन काउंटर बना रहे हैं तो प्रीवियस टू आउटपुट जो हमारा बी और बी ए है उनका कॉम्प्लीमेंट्स का कॉम्बिनेशन होगा। तो बी का कॉम्प्लीमेंट ये रहा और ए का कॉम्प्लीमेंट ये रहा, इन दोनों का एंड ऑपरेशन करके क्या करेंगे, डायरेक्टली हम इसमें दे देंगे। और ऐसे ही ये कंटिन्यू रहेगा। अगर हमें सपोज एक स्टेज यहाँ पर और होती तो हम इसके इनपुट्स को किससे देते, इसके इनपुट्स को कैसे देते, यहाँ पर हम एक नैंड गेट बनाते, सॉरी एंड गेट बनाते। ठीक है, कनेक्शन हम बाद में कर देंगे यहाँ से। तो इसके इनपुट्स क्या होते, इसके इनपुट्स होते, सॉरी हम मैंने थोड़ा यहाँ पे गलत बना दिया। इसका इनपुट क्या होते, सी और बी कॉम्प्लीमेंट और ए कॉम्प्लीमेंट। ठीक है, और इसको हम क्या करते, इसको हम यहाँ पर कनेक्ट। अब मेरे हिसाब से आपको डाउन काउंटर बनाना आ गया होगा। ओके, एंड चलिए सर्किट आपके पास है। आई थिंक इट्स टाइम फॉर द टुडेज क्लास and we will see the circuit again for a short time. Okay, so let me quickly take your attendance. Important part, not that much important, but